så på titlen, ja. Det ser ut som en sånn passende samling. Som sagt, jeg synes det med den boka, du kan godt ta den med, men det litt sånn avhengig av hvor mye tid det igjen til det.
Den var ikke så fryktelig lang, så jeg leste gjennom den I går.
Nei, men liksom, du kan jo ta hele boka, men liksom bare hente ut sånn her og der. Det helt klart. So, okay, I think we should be ready.
Har du endret det for konvekt? Det stream sånn, eller?
Det gjort om hele greia, så nå det liksom sånn YouTube-streaming på toppen, så jeg finner ikke denne teamen lenger. Jeg kan invitere teamen med, så jeg må prøve å finne ut av den serveren. Den dykker ikke opp, så det blir GTL-kontoen som valger å invitere.
Ja, jeg kan se på.
Ja.
Se på det.
Yes. Da bare prøver vi å se.
Right, so I'm going to talk about Bitcoin, which most likely most of you guys have heard about earlier, but maybe you haven't looked that far into it and doesn't completely understand it. But this is the original paper published around 1 to 2 months before Bitcoin was finally released. And it's made by a person with a sort of alias, Satoshi. But some people say it's Australian, some people say it's a group of people. Nobody really knows to this date who created Bitcoin at all, which is kind of cool in one way.
Wasn't there some blessed in the media a few months ago where they thought or something that they had found it?
Yeah, there's a lot of
Rumors.
Yeah, rumors. People think they know him. I think the list is like 5 people or something. But there's a good reason. There's a good chance he's Australian, and there's a really good chance the Australian government knows about him due to tax reasons, because he's filthy rich. Because I'm going to get back to how to earn money on this, but like the earlier you get into this, the more money you make. And since exchange rate currently is 1 single Bitcoin goes for $604, which is almost 5,000 kroner. It's insane, especially since it started out with like 1 Bitcoin costs like $0.50 or something. Insane return on the investment. But so the paper. So this is the paper published before Bitcoin was made, and well, before any real large attempt at a cryptocurrency was made. And this is a purely peer-to-peer electronic cash system that has no centralized authority at all. Like, for example, with your credit card, there's a centralized bank that knows everything and handles everything. Here, the collective of the users serves as a centralized authority, more or less. And the majority of the users is the trusted authority. We can come back to it more. And he, I think to scroll this on that, goes into here talking about like how things work currently. Like there's a lot of trust in the centralized authority in the current system, and that has some drawbacks. Like if the bank suddenly wants to clear out your account, cool, they can do it. You lost all your money. And like there's a certain percentage of fraud and everything. But like currently, when this paper was written, he talks about how there's no way of making payments over a communication channel without a trusted party, like a bank or something. So we need an electronic system that sort of solves the double spending problem using a peer-to-peer distributed timestamp server. But I'm going to get back to that. And the way they're solving this is also by CPU power, which I'm also getting back to. So more or less, the most important part of the Bitcoin network is the blockchain, which actually is more or less the most useful thing they made, because the blockchain has been reutilized in different applications, which I'm coming back to later. But more or less, it's a sort of a continuous line of transactions starting from what's called a genesis block at the beginning, and then link transactions downward, and with sort of 10 minutes interval, there's a new block like the genesis block, just not the first anymore. And here, the incoming transactions are more or less handled with private public key pair. We sign it with your private key. I think most of you know how a private public key pair works. I don't need to go too much into detail with that. And the entire blockchain, from start to end, is one continuous line. There's not like a tree structure or anything. There's only one line that serves as the defining history, more or less, which is an important concept. And more or less the way they're handling the double spending problem. And if you don't know, the double spending is like, if you have $1, how can you prevent it from spending it in 2 shops, for example? How do you know that this dollar actually has been spent earlier? And the way they solve it here is using a timestamp server, or the concept of it, which is more or less that the first time you spend it is the valid one, and if you try to spend it later, it's just invalidated. Because in this system, all of the transactions, each time you want to purchase something, you need to say that to the entire network, or you say it to a subset of network that distributed peer-to-peer to the entire network. So more or less the collective of everybody invested in Bitcoin is working on the same blockchain and knows about every single transactions. And just for the fun of it, I remember. Yeah, the largest transaction in Norwegian kroner currently is 2.3 billion Norwegian kroners, by the way. But then again, they have a lot of measures for privacy, so we just know about the actual numbers being sent from one place to another, not who sent them. Which is one of the reasons criminals have a tendency to get into this. There are a lot of other honest people. Yes, so timestamp server using hashes, and in order to, like, because we have this continuous line of transactions, we sort of need to have a way of determining which one is the correct one, because like as a criminal you can just keep adding invalid payments more or less to the blockchain. But it's based on proof of work, where the honest nodes, those who just want to contribute to the common interest and be fair and honest, sort of give their CPU power to verify these transactions using proof of work, which is more or less that you have the hash and you try to compute the hash by adding a noise value, which you just keep increasing and increasing and increasing and testing different values until the hash starts with a certain numbers of zeros, which is more or less impossible to do without just purely testing and testing and testing. So it requires a lot of CPU power. And the more time someone found that, because it's really easy to see that with that noise that you get the certain amount of zeros in the resulting hash, but it's really hard to find them. So it's really easy to verify that someone else has done the work and verify this block, but it's really hard to redo that work. Because like, if, let's say 5 people find 5 hashes on one block, that's sort of 5 bolts on that one. And then if a criminal wants to create a separate story or a separate chain or something like that, they need to do those 5 blocks and another one, which is a lot of CPU power, especially since, for the most part of it, the majority of the network is legit, and there's only one chain going downwards. So more or less the network runs in the following way. New transactions are broadcast to all nodes, and just for the fun of it, it takes around 30 seconds for the entire network to know about the transaction when it's been pushed. Then each node collects the new transaction into a block, works on finding this proof of work, finding the amount of zeros with a noise value, which is just more or less a value that we increment. and then broadcast that proof further, and node accept testing if they are valid by different means. So you can't just like say suddenly someone transferred all bitcoins in existence into a single wallet. That's not doable. It needs to be linked to where the bitcoins came from and everything. A lot of security built into the system, and then nodes can keep improving the security or the amount of proof of work on the block by continuous to working on it. And then again, all the blocks consider the longest chain of work to be the correct one. So like criminals might always try to add new blocks saying something different, but the majority of the CPU power will work on the honest one as long as the majority of the people are honest, which is a big part of it.
You mentioned that every single node receives every single transaction that's being performed on the network.
Everything is in one line, and this is one of the big flaws of Bitcoin, because since everything is in one line and new blocks are generated at 10 minutes interval, it in effect can only handle 7 transactions a second.
Okay, so how do you scale this?
It's not doable.
Okay.
That's one of the flaws, and that's one of the reasons, take it back, is that Bitcoin was not created to replace your credit card, not meant to be used for purchasing in a shop, because it takes upwards of 1 hour to confirm a transaction, and you can't like stand around in the supermarket for 1 hour waiting for a transaction to be confirmed. Instead, this is more or less meant as digital gold, as a storage for your value in a really secure way online. Like, because if you store your gold like in your basement, I can come and steal it. If you steal all your money in Bitcoin, if you store it there, then unless I get your private keys for the funds, they are secured. And it's a lot easier to secure a small key instead of the entire vault of gold, which can be just physically stolen. But then people really want to push to use this for other applications, and there's ways of doing that, which is actually a PhD student here at this school working with Marius looking into solutions. But currently, it can only handle 7 transactions per second. As far as we know, it's starting to reach the point where it's over. There are 2 more transactions than it can handle currently. So the developers are also looking into ways of solving this. But I just need to say again, this is not supposed to replace your credit card for buying stuff.
But how has Bitcoin become such a big thing when it can only handle 7 transactions per second?
It doesn't say 7 transactions outright almost anywhere, and sort of it's a huge hype train behind this. And then come on, like if suddenly the Swedish kroner increases in value by 604%, 604 times, you're probably going to get interested and want to buy into this. And it's really cool with a cryptocurrency, but in the long run, for the average consumer, like spending this in the shop, we're going to need a new system. But this serves as a sort of basis and a first version, more or less. And later I can probably talk a bit about something called, I can't pronounce it, Ethereum, which is sort of builds upon Bitcoin, which can be used in the way I talk. Anyway, I have this huge network which requires an enormous amount of CPU power, because like if I as a criminal just get hold of a few supercomputers, I can easily overpower the network if there's just some individuals working on adding this proof of work, adding some security. So people need the incentive to do this, and there are more or less 2 ways of sort of getting a reward for sort of giving your CPU power to the network. The first one is that with each of these blocks generated each 10 minutes, there's corresponding amount of coins you gain by this. It started out with 25 coins per 10-minute block, which sort of says why the creator of Bitcoin that run this network by its own for like a few weeks is filthy rich right now. But this value keeps decreasing. It's I think it's decreased by half each 4 year or something. So currently it's 12, I think. So it's keep decreasing, and the network or the amount of work required for generating a single block is sort of always adjusted, so it comes at a fixed 10-minute interval. So the more people invest their CPU power into Bitcoin, the harder it becomes to generate a new block. So currently, like back in the old days, you could just use your average computer to generate new blocks. That is not energy efficient anymore because you spend more money on power, like your electrical bill, than you get back in Bitcoins. So the only way now is with clusters of specially designed hardware that barely make any money. So it's sort of one of the faults that the more people invest into this, the harder it gets for everyone. But the other way of making money here is transaction fees, because when you want to send, let's say you need to have 1 Bitcoin and you want to send it to someone here. If you just send the 1 Bitcoin with no transaction fee, which is purely optional, you might never see it be sent anywhere because nobody wants to compute the transaction for you because there is no reward except finding a new block. And in addition, the network might be over capacity, so some people might come before you. But like if you give them an optional transaction fee that is rewarded to the person that handles the transaction, then your transaction gets pushed to a lot faster. And with the decreasing return on each new block found, which is now 12 and soon will be 6 or already 6, I'm not sure, but just keep going down until it's 0. Then the only thing people can gain from sort of giving the computational power to the network is those transaction fees. So that might be a problem in the long run. And he goes into, yeah, he's also talking about how you can reclaim some disk space, because currently the entire blockchain is around 64 gigabytes of data, which is starting to be a lot to just have on your computer. So there's also a way of simplifying this where you just have part of the network on your computer and work on just a small part of the blockchain, more or less like the latest part. And also talks about like you need to combine, because there is not technically one place where your money is stored like a big vault in the network. It's more like the output of previous transactions, say that like some kind of because like you have this private and public key pair, and your public address received some funds, but you can have different addresses, and you're supposed to have a different address for each transaction there. And then you might have your money spread out all over the place. So sometimes, like if you have got half a coin from one friend, half a coin from another friend, and you want to send one entire coin to a third friend, you need to melt them together. So one transaction can have several inputs and fewer outputs. So like you can take in half a coin there, half a coin there, melt them together and send them to a third party. But then again, the more inputs you add, the more work it's required. So like if you're melting together 10,000 smaller coins, you're going to add a lot more, need to add more transaction fees in order to get it through, compared to like just sending a single coin, which is already combined. And of course, there's a lot of privacy in the system, especially since they want people to have a separate key pair for each transaction. And then again, here you can see like publicly in the distributed blockchain, you only can see the transactions, not like the person who sent it. And this doesn't say in the paper, but I talked to Myers a bit, and like imagine you are a government, part of the government, and you're in the police, and you know that some criminals in the country is sending bitcoins back and forth and using it to purchase services. There's no way in this system you can find out who they are, unless at some point that they sort of try to exchange these bitcoins for example, dollars, because most of the exchange requires some identification, and then you have them. But inside the network, there's nothing you can do. You can just see that one address sends money to another address, and each address is unique and created just for that transaction. So who knows? Who knows who sent it? So that's one of the main reasons for criminals doing it, but also people, because like you want to be anonymous. And then he starts talking about how criminals can overpower the network, which is more or less if you have more than half the CPU power alone, then you can sort of dictate Bitcoin as you want to. Like you can say that this transaction happens, not these ones. So like the biggest fear in Bitcoin is that if a criminal network gets more than half the CPU power, Bitcoin just falls apart instantly. And that's more or less the same with all cryptocurrencies. Currently, there's no problem because like you gain a lot of money from investing your power, so that's an insane amount of CPU power invested in it. But as the reward for adding your CPU power decreases with like these 10-minute blocks going down in value, people might stop investing power and Bitcoin might actually fall apart. And in addition, so here I actually include a code of how to calculate this, but this is kind of strange to add in here. But then again, if more than 50% gain power, more than 50% of CPU power is from a criminal organization, it falls apart. So it's technically really important. And this is a really, really nice paper to read, which is really concentrated in its information, and it's really obvious that he left out parts and focuses on the important stuff there. And this is actually based on something he made rather than just a lot of other papers that just talk about something in theory and just do and done, keep going. This is something he worked on a lot of time before and worked a lot after, but he's not directly involved with the project anymore. He or whoever he is. We don't really know.
So why don't people want to take credit for it?
Yeah, let's imagine you created Bitcoin and you have a few $1 million in Bitcoins. Who wouldn't want to kidnap you? And imagine all the taxes you have to pay. And really interestingly, I read on a Norwegian news page yesterday or the day before that about Bitcoin, because there's a sort of interest group created in Norway recently for Bitcoin, and they wanted to have a bank account in DNB in order to like do the exchange and everything, but they actually was denied because DNB thought they was working with terrorism. And that's one of the major challenges, that a lot of people think that if you're using Bitcoin, then you are a criminal.
When was this?
I can send you a link. I think it's 2 days ago.
2 days ago. Oh. Because my memory says that DNB or some Norwegian bank authority has invested in blockchain technologies or something like that.
Yeah, DNB actually talks about Bitcoin on their website. So it's kind of strange, but they're scared of new stuff. And yeah, it's not just DNB, it's like deeper in the network of payment gateways and payment processors. A lot of them are really scared of Bitcoin and just refuse them. And like if the US government has it their way, they're going to add. Oh,
This is strange. It's recording what we see.
and I don't know if you care, but Bitcoin handles 7 transactions per second, and the largest other network, the Visa network, we can handle 43,000 transactions each second, just for comparison. So, any questions?
Yes.
Yeah.
How would quantum computers have an impact?
I have actually looked into that a lot, and they're actually the creators of Bitcoin say that since that will only happen around 2030, 2040, it's most likely not going to be a problem because they have designed the network so they can sort of more or less hotspot technologies. But the key, the private key, public key system will be broken. So if you get a public key for a transaction, you can so more or less reverse engineer the private key. But since it's more or less hidden and only used once for one transaction, it's partially hideable. And by that time, we usually have a new system that I can sort of hot swap it with. And like they're continuously working on, and the code for Bitcoin is on GitHub if you want to look into it and work on it. But still, they say that it's so long until it's going to be a problem that they don't really see it as a challenge currently. But it will be a problem once quantum computers arrive, and most likely the NSA is going to have quantum computer 10 years before anyone else. I'm afraid.
So the idea about Bitcoin is that it's completely anonymously. If you have not any links to the money you are spending within the network yourself.
Yeah, it should be anonymous. It's there. And as I said earlier, it's supposed at least to be like digital gold, but it's too fluent currently, like it's going too much up and down the valley, because one of the reasons rich people want to invest in gold is it keeps its price steady. So unless Bitcoin reaches that point, it's never going to be digital gold. But if it reaches stability, then it can be served as a form of digital gold, a way of storing large values easily without having to put them in a bank that can suddenly go under.
Okay, let's do the final paper later. Yeah, so the paper I will discuss is open user profiles and adaptive new system, help or harm. So this paper mainly tries to explain how they created a system that will that will try to recommend news to users who use the system, and they put a lot of stress about the adding transparency and controllability to this adaptive news system from the users themselves. So how can users interact with the system so that the recommendation process is more personalized and more direct to the user's needs? So they present a personalized news system, which is called Your News, and which allows users to view and edit their interest profiles and report user study on the system. They say that adaptive news systems belong to one of the most popular type of personalized web-based systems, and that they try to put a lot of stress in the way that taking into account users' interests and preferences, adaptive news can be way more interesting for the users, because even though recommended systems work quite good, if they put a bit of control, if they put a bit of input from the users in terms of regulating this recommended systems, they can get a lot of good output from the system, so that the news are as much personalized as it can be. So they try to explain how a specific person or user, when they go to this news system, they try to build a model, or like they call it a user model, which is built by users going through news and then browsing, exploring them, trying to find what is interesting for them, and so that using this information they can further classify information based on their interests. They also say that we believe that transparency can be applied to address the problems of trust and control in adaptive news system. So they say that they concentrate on the application of open user models in providing transparency to adaptive systems. So let's just go ahead and talk about the personalized news system, or the Your News, which is a web-based system for personalized news. And so what the system does is, as soon as the user enters the system, there's basically no data for the system to recommend specific news. But as users go ahead and try and browse specific content, then the system tries to analyze the document by taking words that are mostly frequented in the document and using those words as seeds or as training data in order to recommend future news. So what they try to they define this news as short and long-term news, where short-term or profiles, where short-term profiles consider only the 20 most recent view items, and long-term profiles consider all the views that they have done throughout the history of their browsing. They also define this recent news and recommended news, whereas the recent news presents the 100 most recent articles ordered by time, and the recommended news is the component, or the part where the systems come into play. And so, like, by analyzing all the documents that are fetched into the system and using the model that the system created from the user's history, or these words that the system has accumulated and used for training, then they start to analyze the documents and try to find the interesting words inside the documents. And as soon as they get hits on the words, they try to like list the most important documents, or documents that got them the matches with the similar words on top, because users tend to read the articles that are on top of the rank list. Yeah. So, however, they say that the long-term model did not play as great role as it does, because the study, the duration of the study was relatively short, so they could only experiment with the short-term articles. So in this figure, figure 2, you can see how they model the system, where users can see, for example, which words are more stressed and that are used for the system to try to match with other documents. And what they can do here is that they can add new words to the system, or they can remove existing ones. So they believe that by manipulating the recommended systems, by adding or removing words, the users have a lot of a good control on the system, and they can try to modify it for their preferences, so that the system can recommend news that are specifically targeted to their interests. To be able to validate, or let's they have here some research or hypothesis. They claim some hypothesis by saying that the experimental system, where users help the adoption process by manipulating the open user model, performs better. So they try to say that if so when they try to run an experiment where they will have the recommended system recommend items, but without the part that the user can modify the system or can add words into the recommended system, and they have this experimental group where they can have the opportunity to modify. So they say that the experimental system, when the users can manipulate with it, it will perform better in terms of having more articles that are relevant to the user. And so they have like this sub-hypothesis where they see that the experimental system will generate results with high precision in terms of ordering, So the higher up the article is in the ordering list, the more relevant is to the user. And users of the experimental system will demonstrate higher task performance. And the second hypothesis said that on the subjective level, users prefer the transparency of the user model in the experimental system. So they kind of show positive feedback in terms of like the opportunity of the system to allow the users to make changes on the recommendation process. So the experiment, they recruit volunteers from the University of Pittsburgh, and they define two topics, so that every volunteer has to go and read about these topics, get familiar with it. And the first topic is about health, and the second topic is about national. So in the first one, they tried to, in the national topic, they selected school security, and on the second one for health, the health topic, they selected food contamination. So they gave tasks to the user in order for them to go and read about these articles and get familiar with them, so that later on, when they use the system, they can try to define if a certain article is relevant for that specific topic. So either school security or food contamination. So this was done in order to validate the recommendations that the system makes. And so the study is divided into two groups. The first group uses the systems without the ability to make changes, and the second group uses, or the experimental group uses the systems where they are able to actually make modification into the system by adding additional words, removing specific words, and so forth. So here we have the results and discussion about this. It's important to mention here that when they try to rank the or categorize the articles that the system recommends, they try to put them into 3 different categories. The first one is relevant, which means that the article is it's relevant and it matches the topic. Not relevant means no relation of any nature to the topic, and marginally relevant, which means there are some words or linguistic matches that occur inside of the article. And we can see in table 2 that for the national article, they found that 154 top articles were not relevant to the topic. 53 were marginally relevant, and 712. Well, the numbers here, we can see that there are a lot of items that were relevant for the national topic, whereas for the health topic, you can see that they're quite similar, the number of not relevant and relevant items. And they try to explain this phenomenon because so the reason why this is happening is because the volunteers who run the experiment were not very familiar with the health topic compared to the national topic. So they lack the knowledge to determine what information or what keywords were important for the health topic. So the system performance analysis, in this figure we can see the average precision. So the baseline and the experimental study. So they divided the experiment into 3 stages. For example, when they took into consideration the list, and in the 3 stages we got so the items ranked from number 1 to number 3. For example, if there were nine items recommended into the list, the 3 stages would compose items from 1 to 3, 3 to 6, and 6 to 9. And on the y-axis we can see the precision. So how precise was the system in terms of recommendation? And we can see that the baseline actually performs better than the experimental system. So just to show you the idea here about this experiment and how important or how bad the control the user's control into the recommendation system is that the more the user has control into the recommendation system, actually the performance is worse. So here they say that the initial results contradicts their first hypothesis, where they say that if users modify the system, then the recommendation process is better. Actually, the more input the users put onto the recommendation system, the worse the results. So if we go down, we can see like this figure here shows the keyword manipulation versus system performance. So the more manipulation there were on the system, the performance started to decrease. And one of the reasons they argue about is that the familiarity of about the topic, because users did not specify the correct words into the system. So so as more words they put into the system, the recommendation got worsened. And because they had to go to each article and start to read a bit about it and then define if the article was relevant or not relevant. After they did this manipulation, the number of irrelevant articles actually increased. And another interesting thing is that if they removed words from the system recommendation part, this started to worsen the system more and more. After this experiment, they also run a post questionnaire where they asked the users about the topic familiarity, sufficiency of news, trust of the system, control of system, and overall satisfaction. This was for both systems, where exceptionally for the experimental system, they also asked to rate the utility of the user model for adding, removing, and displaying terms. Well, to conclude this whole article, they say that the study confirmed the controversial results, where they say that the ability to change established user profiles typically harms the system and user performance. It is important to specify here that user manipulation into the system has to be very much controlled. And for example, removing items from the recommendation system should not be provided, because if you remove items, then the system will not be able to match other documents to be able to recommend to the user. And they say that they're working on the system, and they are trying to modify the part where the user has control. But this will be for their next study, I guess. Yeah. I didn't have much time to get into reading in detail this article, but the idea is that having control into recommended systems can be good, but too much control, too much input into the recommendation system can actually harm it. So instead of improving the recommendation accuracy and diversity, you will actually harm it. And it also depends on the user knowledge, like how good are the users in terms of providing good information to the recommendation systems. So
yeah, it's interesting to see if you look at question number 5, which is their feedback to whether they like, I mean, the star over there, they like to add new terms. The first session, they were quite happy about it, 4.10, but they realized probably that it was too much work or it was too hard, and that it really negatively contributed. So then the second session, they're down to 2.9. So initially it seems like this is the idea of agency. They feel like, okay, now I'm in control, it's good for me, but then gradually they realize that, okay, being good means more work, and it negatively impacts the performance.
yeah, so the system, as soon as they put words, as soon as they change the system, they got the results immediately, so they can immediately see what happened with the recommendation list. And they saw that as more control they put into it, they found that the articles were less relevant to the topic. So
yeah, so I think it's of course this is in a way proven by this paper, but I think that it's not just a matter of the users not being competent in the area. I think it's also hard for a user to really understand the complexity of a model and the impact of a model. Even if they were experts in the area, I think it's still going to be very hard to exactly say all the, because a term that doesn't seem to be very relevant, it may have kind of what's called the latent semantics, maybe still be very strongly related to what you are interested in without you knowing and noticing. So I think it's I like this paper because it's kind of like they really show that their hypotheses were totally bad.
yeah.
User control is not necessarily a good thing when it comes to user profiles and models. Okay, thank you. So next week, I think we'll drop your paper, or you would like to present next week. It's up to you. Yeah. And then we'll spend time on Lars' presentation and talk about your projects.
Yeah.